Hi, Doug here. So I threw together a very quick little power supply. So I'll run you through the quick components of it. This is about the bare minimum you need for a power supply. I have a dual pole circuit breaker for disconnecting both sides of the circuit. I have a variac. I have an output capacitor bank, and then a bridge rectifier here on the heatsink. So basically, I can turn it on, and that applies power to my variac. Now, because the pen already had it, I used it. There was a current transformer with a gauge in the front, so it monitors the input AC as well as the little indicator light. So now I can go ahead and turn up the output, and that then goes through the rectifier, converts the DC into the cap bank. Now, capacitance on an unregulated power supply like this can be kind of tricky. So I've hooked up to a scope here. Let me turn off mine. The line you see, the top line, is this power supply. It's a regulated 20 amp solid state power supply. You see it's pretty stable output. It's got slight wave to it. So if I bring mine up and put it on top of it, see they're pretty well in spec. And that is under load. I'm using a 300 watt light year as my test load. So I'm going to disconnect this capacitor. It's a 30,000 microfarad capacitor. I'm going to leave that bank connected. And you can watch the difference here. So there's disconnected, there's connected, disconnected. And again, that has to do with the load on it. So your capacitance level needed to smooth out the waveform will depend on the load. Again, there's a lot of formulas for figuring that out, but just basics, just wanted to show you that. So over here is the current side. And I have this gauge, which is an old school analog gauge, has the built-in shunt resistor in it for the voltage. This is 0 to 10 range. And you can see with my test load here, it goes up and down. Now let's say you didn't have access to an actual current meter. So to show you can pretty much use anything, back here I have a fuel gauge for my vehicle. I didn't know any of its specs or any of its values. So what I did is I hooked up this resistor block. This came out of an old robot. You can see there 1 ohm, 4 ohm, 5100, a bunch of different large current resistors. And I have a voltage divider here with a large wire wrap resistor and then a variable resistor so I can dial it in. Because again, I didn't know the values. So once I find the value, I can then find a hard resistance for it. Voltmeter here is hooked up directly across the 1 ohm resistor. So if I turn up, you can see there where it shows 0.8 amps, 0.9, 1 amp, so forth. And if I zoom in on this gauge in the back here, I have it set up so 2 amps is full gauge, and then bring it up a little bit, 1 amp is at half, and so forth. So I'll give you an example. There it is at half. There I am at 1 amp. So if I take it up to full, I'm sitting at 2 amp. So that's how that guy works. And that can pretty much be done with anything. You can use, like, here's a shunt transformer. This one here, you can pull the voltage off if you had to. You can even use old analog voltmeters as your gauges. They're kind of nice. They have built-in networks already ready to go. You can dial them in and just change your scale on there. So this is the power supply. I hope this was somewhat helpful. Any questions, let me know.